Hi, I thought I'll do just as a quick video rather than trying to explain. Sometimes videos are clear. One of my readers, users of the site, went and tried some of the experimental reports and reported some bugs in them. And I looked at it, and sure enough, there were bugs. Not only that, these were originally produced probably 9 or 10 months ago as it says, as experiments, and then largely forgotten about it. So what I've done is gone through them and hopefully made them more useful and actually more correct against the data which we have. So here is the cases is the same autism child which we talked about, and let's start with compare symptoms. Compare symptoms goes and shows all the symptoms are in common, and there's a threshold. When you go and look at probable symptoms, there's a magic number on the far right, and usually my suggestion is you want 0.6 or above. If you go to 0.8, so higher predictive value, you end up with less, in fact just 3 of them. And what you can do is when you take a look across, you can see where that symptom appears to drop below the threshold and stay there and appears and then disappear, and just one symptom suddenly has become significant. So what it does do is give a general indication of the health of a person. The more symptoms that shows up on one lab report compared to another, the more likely it is that there's a deterioration of health, especially if it keeps for 2 or 3. Let's drop this down to 0.7. Do an update. Oops, sorry. And what we see is we have a whole stack more. Some of these appears for a short time and then disappear. Some are reoccurring and then stops and disappears for a while, then comes back, which means you're probably borderline with the bacteria just associated with it. Other things are singletons, which means it's probably just a temporary variation of bacteria that happens to match things, and then upward you see other things are pretty consistent across the board. And if you jack up the sensitivity at 0.85, then the number of items ends up being reduced. In this case, to just the 1, which we happen to know is a correct diagnosis for this patient. Okay, so that's one of them. Now let's go back and do a change samples. And we'll go back and compare samples to each other. And again, we omit the mother. And let's try the compare bacteria. And what we have is we have the bacteria. Again, this is a sortable table, so you can sort it by whatever thing you want to do. For example, the class. Happy face means the values are in the middle range, that is somewhere between the 25th percentile and 75th percentile of common readings. Minus indicate it is below the lower 25%, in this case 93% below, 97% below. Here you have no value, which means there's no measurable value. So we saw a case where the alpha protobacteria were fine, or now fine, but if you go back time-wise, they weren't. So they have somewhat normalized. A positive number means it's above the 75th percentile, and it's a percentage above the 75th percentile. So in some cases, like 8, it's just a little bit above 45. Other cases can be quite a bit. So that is the comparing bacteria over time. I'm just being able to look at the numbers. I have a happy smiling face. Blank means no measurement received. Negative indicating below the 25th percentile. positive, indicating above the 75th percentile, how much above. So usually a 2-digit number above is not much of a concern. 3-digit number is a concern. Going back here, and we do this once more. And we look at end products. End products goes and allows you to just quickly scan down. The end products are filtered to those where some sort of end product is reported for at least 600 people. So you have, when you hit all 000s, it is a improbable or low probability things, because in theory 50% of their samples, in this case 12, there should be 6 samples which are showing up on the chart. So coenzyme A would appear to be an item of concern, and we can go elsewhere to find that. So that's basically the short of it for these 3 former reports, which have now been updated to be more usable. And I'm going to just hop in and do myself to see how stuff shows up there for me. Age 60 to 70 is consistent across the board. Blood type A is 0 is consistent across the board. Again, I have a large number of items there, and what I'm going to do is I'm going to jack it up to the most significant. And we still have a fair number of items, just down to 10. And we have the brain fog, which happens, fatigue, which happened for a while there. And onset was 2019. And there, and I believe I got something to fix because the sequence of data is wrong there. So just be aware of that. And basically goes across. We can go back to change samples, compare, look at end products, and we again, I see a bit of or 2018, 2019. So this is incorrect date sequence. And what you can do is just take a look down and see if something is particularly odd or problematic. And in my case, again, the coenzyme A is absolutely nothing, which is similar to what the last person has. But that will give you some idea. Some cases where things bounces around back and forth is often because of a particular bacteria coming in or going out. Okay. Last quick example, another child with lots of microbiome, this time from uBiome being done for the child. We can go and compare symptoms. We have the usual big stack of them. We'll increase it to 0.9, see if something dominates. And what we have is we have autism as the dominant characteristic. We go down a bit, and we have fatigue as being a very dominant characteristic going across time, sort of improved a while and then disappeared. And then we have immune bloating showing up for a short period of time. But the main thing it does is it provides the ability to identify dominant predicted symptoms and work from there. Here I did 0.75 and made no real major change. So that sort of is a quick description of what I have done today to improve the